Hello and welcome to another lesson from Simply PE, this time looking at the lever systems and mechanical advantage. So for this topic, what do you need to know about levers and mechanical advantage? Well, first and foremost, you need to be aware of the first, second and third class lever. So there are three types of levers. You also need to be able to draw and label each of those class levers, and hopefully be able to apply different sporting examples and movements to each class lever. And then finally have an understanding of the mechanical advantage, what it actually means, that term, and relate it to the three class levers. Now, notoriously, this topic is sometimes seen as one of the most difficult topics at GCSE PE. So take your time as you go through this presentation. I will try and break it down as well as I can for you. And if you need to rewind, pause the video at any point, then make sure you do that so that you get a clear understanding of each class levers. But don't worry, we'll take you through it. So before we do anything else, let's get an overview of basically what do we mean by a lever. So when we think about levers, we're talking about movement within the body. And a lever will consist of three different parts to it. Okay, so there's three basic parts that equate to a lever. The first part is known as the fulcrum. This essentially is the joints within the body. So we're looking specifically at GCSE PE, it will be like the knee joint, the hip and the elbow, and possibly the neck and the shoulder. Okay, so this is where bones come together. That's what we mean by a joint. So it's the pivot points when we talk about the fulcrum. And you can see there on the diagram that it's normally shaped as a triangle when we actually draw out the different class levers. The next component is looking at the effort. Okay, so this is the force that is applied to the movement of the resistant or of the load or of the weight. So by that, the movement that's applied, so the force, okay, and that will be generated by the muscle. And that normally will be indicated via an arrow, okay, so either pointing downwards or upwards, depending on which direction the effort is being applied. And then the final aspect of a lever, when we look at its overview, is the load. Okay, so this refers to the resistance to be moved in the lever system. So the actual weight, okay, that is being moved by the effort. And the load or the resistance is normally categorized as a square or a rectangle, as you can see in the diagram on the right. So the first task, very simple task, I want you to draw out those symbols, I want you to label them so it helps you to memorize the components of the lever system. So how do we remember the three different class systems? Well, we can use the mnemonic FLE, okay, and each of those letters will represent what is found in the middle of each class system. So when we look at the first class lever system, we have the letter F. So fulcrum is located in the middle, and you can see on the diagram to the right hand side of the presentation, the fulcrum, the triangle, is located in between the effort and the load. That's what we mean by a first class lever system, and I'll go through that in a bit more detail on the next slide. The second class lever system, in the middle of it is R, which refers to as the load or the resistance. So that is what's located in the middle of the second class lever system. So fulcrum will be on one end and effort would be on the other end. And in the third class lever system, E for effort is found in the middle of this system. So load would be on one side of effort and fulcrum would be on the other side of the effort. So again, pause your video here and I now want you to draw those diagrams, okay? And you'll be able to notice that actually the arrows on the effort point in different directions, and we're going to talk about that in a second because that's the force that's being applied in different directions to each class lever system. Okay, so let's get cracking and let's look at what compromises, what makes first class lever. How does it actually work? So often this class lever will be seen as a seesaw shape. So you may have noticed in a school playground or in a child's playground a seesaw before. And if you think of that seesaw shape that you can see in the picture, The fulcrum, the pivot point, is in the middle. Okay, and actually you can see on that diagram there, the top left one, the chap who's sat on that seesaw, okay, that would represent, let's say, the load, and you can see the seesaw is down at one end, the left-hand side, because the load, the weight, is pushing it in that direction. Now, in order for us to move that guy on the seesaw, we need to apply some effort to that, and that's why you can see the effort arrow is pointing downwards on the right-hand side of that seesaw. So in order for us to move that load, we would have to apply effort downwards. And you can see the load is on one side, the effort's on the other side, and the fulcrum is therefore in the middle. So that's kind of what compromises a first-class lever. So as it says there, the fulcrum lies between the effort and the load. An example of this within the body is seen at the neck joint. Okay, so what I'd like you to do is to pause your video here, and I want you to see if you can just, in your own words, explain how the neck joint is seen as a first-class lever. Okay, so hopefully you've unpaused the video there, hopefully you've written down an answer to that. So when we look at the neck joint, you can see in terms of the fulcrum, where the actual vertebra, where the neck meets the actual cranium, that would be the pivot point, okay? So where the head can move forwards and it can move backwards, and that would be where the fulcrum is, okay? Now, the load is predominantly at the front of our head, and that's why, for example, if we had no effort applied to it, our head would just drop forward and drop down as I'm doing in the actual video itself, okay? But we have to apply some effort in order to keep our head upright, okay? And we use the muscles within the back of the neck, okay? And that helps, obviously, in terms of the effort to move the load. So a neck joint will have the fulcrum in the middle, okay? It will have the effort at the back of the neck, okay, which is helping to move that load, which is at the front part of the cranium. And that's how the neck joint is a first-class lever. Okay, so next let's look at a second-class lever. How does it actually work and what do we mean by it? So first and foremost, I want you to try and envisage and think of a wheelbarrow. So if you look at the picture at the top of the screen, if you've ever been in a garden, you might have seen a wheelbarrow before at an allotment site, for example. A wheelbarrow is an example of a second-class lever. So the wheel at one end of that wheelbarrow, okay, is the pivot point. Okay, and that represents kind of the fulcrum, okay, if we had a joint within our body. The middle section, as we know in a second-class lever, revolves around the load or the resistance. Okay, so that is what is found in the middle of a second-class lever, and that'll be the same in terms of this wheelbarrow instance. Now, in order for us to actually move that load, we would have to apply effort upwards to lift the wheelbarrow by the handles on the left-hand side of that wheelbarrow, and the effort would have to be applied upwards, and that would mean that we would obviously be able to move that load upwards, okay, and then eventually forwards or backwards, depending on what we're doing with the wheelbarrow. So the fulcrum here lies at one end, okay, when we look at the second-class lever system, and as it says there, with the effort at the other end. So in the middle is the load or the resistance, as I've just said. An example of this within the body will be seen within the ankle joint. So you can see at the bottom of the screen that diagram, which represents when we look at, let's say, plantar flexion, so we're pointing our toes down towards the ground, the fulcrum, okay, the pivot point, the fulcrum will kind of be closer towards the toe end, okay, and you can see there that the fulcrum lies there, just past the actual ankle joint, in between the toes and the ankle joint itself, and the resistance or the load, which is in the middle, will represent the body weight, and then in order for us to actually do that plantar flexion, and let's say go up on our tiptoes, for example, we need the effort, okay, which will be the gastrocnemius, which will be working, okay, which is at the back of the leg, as you can see there, and that represents the effort. So we've got the fulcrum, okay, on the right hand side there of the foot, of the toes, okay, towards the top part of the foot. We then have the resistance, the load itself, which will be the body weight, which is in the middle, and then we have the effort, okay, being applied upwards in order for us to raise up onto our tiptoes, which would be the gastrocnemius. And then finally, if we look at the third class lever, so this is the most common class lever found within the body. And this can be thought of by thinking about a hammer taking out a nail from, let's say, some plasterboard or some wood, for example, as you can see in the picture. Okay, so the weight, okay, the resistance, okay, represents, you can see there, by the nail within the actual plasterboard or the wood. The effort itself will be us applying, let's say, our hand on the handle of the hammer, and the pivot will be towards the right hand side of that hammer, as you can see there, the flat head end within the actual diagram. So as it says there, most body joints act as this type of lever. So third class levers are the most common found within the actual body. The fulcrum, as it says there, is located at one end. Okay, the load is located at the other end, representing that weight, that resistance. And the effort, okay, will therefore be found within the middle. Now, what I'd like you to do is to pause your video here, and I want you to look at that diagram just above me where we can see a bicep curl. So you can see the ball in hand, okay, and the individual doing a bicep curl, so raising that ball towards his or her own shoulder. So I want you to explain in your own words how the bicep curl is seen as a third class lever. See if you can have a go at that. Okay, so hopefully you've had a go at that. Now, a lot of students initially, when they look at that diagram and when they look at that example, they say, well, hold on, sir, isn't that a first class lever? Because we have the bicep on one side, we've got the elbow joint, which represents the fulcrum in the middle, and then we have the load, the resistance, which is the ball in hand, which is obviously being moved at one end as well. What we've got to be careful of here, guys, is the fact that, yes, the bicep is on one side, but what we're interested in is the insertion. So where the bicep is actually joined to, okay? So you can actually see at the bottom of the bicep, it's actually joined to the radius, and that's actually on the other side of the fulcrum, okay? And that's why the effort is actually in the middle. The fulcrum is on the right hand side, the elbow joint, and therefore the load, the resistance is further away on that left hand side. So that's why a bicep curl will actually be seen as a third class lever. So we've got to really kind of focus on that insertion point, and that insertion point there of the bicep being attached to the forearm, the radius, okay, that is obviously pulling that forearm towards the shoulder. And that's why that effort is actually in the middle, as we would expect in a third class lever. So as you can see here in this example, in terms of an explanation, the fulcrum, yes, is at one end. Okay, here it's on the right hand side of the diagram. We have the effort, so the insertion point, which attaches to the forearm, which is pulling the forearm upwards in that flexion phase towards the shoulder. And then we have the weight, the load, which is at the far end, which is obviously being moved because obviously the bicep is contracting and that flexion is taking place, allowing that movement of the ball and the load upwards. Okay, so that is the reason why this is a third class lever. Okay, so let's now try and apply this to some sporting examples that might come up in the exam. Okay, and let's look at these two here. So you can see the hooker, number 2, looking to throw the ball in towards the line out. Okay, so I want you to focus there on that movement, okay, where he releases the ball. Okay, so that extension phase at the elbow. So what lever is being shown there? And then at the footballer at the bottom, drawing his leg back, his foot back to kick the ball in terms of that flexion. And if you want to have a go at the extension, so the next phase of where he then strikes the ball, so he extends his leg, then have a go at that as well. So pause your video here, see if you can apply those 3 class types and decide what you think is happening in those sporting examples. Okay, so hopefully you've had a go at that. You've unpaused your video now. Let's see if you've got any of these sporting examples correct. Okay, so when we look at the rugby throw, okay, first and foremost by the hooker, so the number 2 there that you can see in the example, we're looking at that extension at the elbow, and this is an example of a first class lever. So the extension at the arm is referred to as a first class lever. So remember, the fulcrum is in the middle of the first class lever. We have now, when we're looking at that extension phase, we're using the tricep. Okay, now our ulnar bone, which comes up to the elbow joint here, goes a little bit past it, so that insertion point of where the tricep meets the actual ulnar, and that helps us to then move our forearm, okay, and extend it, is past the fulcrum point. So that insertion point is on one side, we then have the fulcrum, and then our load, which is the arm or the hand moving, or the rugby ball in this instance, okay, is at one end as well. So we've got the fulcrum in the middle, we have the insertion point here, which is the effort load by the tricep, and then we have the actual weight, the resistance, which is now moving from that throw. So this is seen as a first class lever. So it's really important just to sometimes recognize where those insertion points are, so where the muscle joins up to the bone, because that has an impact in terms of what class lever it is. When we look at kicking a football, so this example here, in terms of that flexion stage, for example, at the knee, this is an example of a third class lever. So again, if we think to ourselves, well, what muscle is actually working here? We've got the fulcrum, which is obviously seen within the actual knee, okay, but the effort, okay, load is the hamstring, which is now working at the back of the leg, and then that, in terms of the insertion point, will be to the lower part of the actual leg. So that's why the effort will be seen as in the middle, the fulcrum will be on the right hand side to one end, and the load, the resistance, which is the foot moving, will be at the other end as well. So the effort is in the middle there for that to be a third class lever. Again, when we look at the extension, so if you try to do the third task as well, so him actually extending and kicking the ball as well, this will also be seen as a third class lever. Okay, so again, we have the fulcrum in the middle, okay, but it's really important to note here that yes, it's the gastrocnemius which is working, and again, we might think to ourselves, okay, well, the gastrocnemius is on one side there of the fulcrum, but actually in terms of the insertion point, that gastrocnemius will go past the kneecap and attach to the tibia, okay, and ultimately that means that insertion point, because it's past the fulcrum, that effort now is in the middle, that insertion point, okay, and the load is obviously at one end, the fulcrum is at the other end, and therefore the effort is in the middle. So that again is an example of a third class lever. Okay, so let's now look at that term mechanical advantage. So when we look at mechanical advantage within the 3 class levers, we're basically just referring to what benefits the class levers have. So which is the most kind of efficient, if that makes sense, which is kind of the best performing when we look at class levers. So this will depend on 2 things. Okay, so if we look at the diagram at the top, we can see that fulcrum in the middle. So this is an example of a first class lever. And we need to be able to look at 2 distances to kind of work out mechanical advantage. The first one is the distance between the force and the fulcrum, okay, and this is referred to as the effort arm. So it's the distance between the fulcrum and the force, okay. The second thing that we compare it to is looking at the distance between the fulcrum and the load, okay, and that is referred to as the resistance arm. So in this first class lever diagram, you can see kind of the seesaw example. The distance is, it's equidistant, looks like it's exactly the same, but levers don't often work like that within the body. They're not always the same distance apart. So we can actually work out mechanical advantage by using that formula there at the bottom, which is worth making a note of. So mechanical advantage equals effort arm divided by weight arm or resistance arm. Okay, so that is the formula that we use to figure out and work out mechanical advantage. Okay, so pause your video here, just make a few notes on that, and then in the next slide we'll see if we can apply it to the three class levers. Okay, so let's try and apply this now to the three class levers. So again, pause your video here, and I want you to look at those three diagrams, the first, second, and third class lever, and use that formula to try and figure out whether you think it is either high or low in mechanical advantage. So use that formula there, try and work out the distances. It doesn't matter in terms of the numbers of how far the distance is, but whether you think the first class lever, second class lever, and third class lever, whether it's high or low in terms of mechanical advantage based on where the fulcrum is, the effort is, and the load is. Okay, so pause your video there.